whereas the distance of this line from the x-axis is 3 units and it is touching the line at 3. So therefore the equation of the line is y is equal to 3. So 2-point form of a line means we have already found the slope of a line when 2 points are given. So that is, it is given by y2 minus y1 by x2 minus x1. What do you mean by tan theta? It is the slope of the line or gradient of the line. So that means they have given you the value of m. So therefore m is equal to 1 by 2. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. Today in this session, we are going to learn about the various forms of the equations of the line. So in the last session, we have learnt the general form of linear equation, that is ax plus by plus c is equal to 0. Indicates the equation of a straight line in the linear form. Now here there are other forms of the equation of the line depending upon the condition. So we are learning them one by one. In this session we are learning about the horizontal and vertical lines and their equation, equation in point slope form, equation in 2-point form, equation in slope intercept form. First one, various forms of the equation of a straight line, horizontal and vertical lines. So we have already discussed in our last session that any line parallel to x-axis will have an equation in the form of y is equal to k, where k is the distance of the line from the x-axis. If it is above the x-axis, then y is equal to plus k, or if it is below the x-axis, then y is equal to minus k. Similarly, here we have the equation of horizontal line. Above x-axis is y is equal to a and below x-axis is y is equal to minus a. Wherever the distance is same, only the difference is the points are different. Next, similarly here also the equation of vertical lines means any line which are perpendicular to x-axis or we can say parallel to y-axis will have the equation in the form x is equal to b or x is equal to minus b, depending upon whether the line lie to the right side of the y-axis or to the left side of the y-axis, because the value of x will be positive on the right side and negative along left side. So therefore x is equal to b or x is equal to minus b represents the equation of a straight line which is vertical. Find the equation of the lines parallel to axis and passing through minus 2, 3. So we have x-axis and y-axis. So minus 2 somewhere here, 3 is this point. So here we need to draw two lines passing through or intersecting the x-axis as well as y-axis. So now this is a line parallel to x-axis. This point is minus 2, 3. And this is a line perpendicular to x-axis. So let this be minus 2. So distance of this line from the y-axis is x is equal to minus 2. So therefore the equation of this line is x is equal to minus 2. Whereas the distance of this line from the x-axis is 3 units and it is touching the line at 3. So therefore the equation of the line is y is equal to 3. So hence the equation of the line which is passing through the point minus 2, 3 is x is equal to minus 2 and y is equal to 3. Next we have the point slope of a line. The equation of a line which passes through the point given by p of x1, y1 and has the slope m is y minus y1 is equal to m into x minus x1. So we know that the slope of a line m is given in the form of y1 or y2 minus y1 divided by x2 minus x1. So where x1, y1 and x2, y2 are the points which lie on the line. Now suppose any point x, y lies on the line, also x1, y1 lies on the line, then the same slope formula can be written as y minus y1 divided by x minus x1. So if we interchange this, we will get the required equation of the line. So here we have a slope as well as a point x1, y1. So remember, to form an equation of a line, we always need two conditions. So here the condition is, the one is the point on which the line is passing and the slope of the line is given. Hence, using the point and slope, we can write the equation of a line in the form of y minus y1 is equal to m into x minus x1. M gives you the slope of the line. So let's take an example. Find the equation of the line passing through minus 2, 3 with slope minus 4. So here the value of m is minus 4 and x1, y1 is minus 2, 3. So therefore, using point slope form, we have y minus y1 is equal to m into x minus x1. So y minus 3 is equal to minus 4 x plus 2, or we can write y minus 3 minus 4x minus 8. Shift all to the left hand side. We get 4x plus y plus 5 is equal to 0. So this linear equation represents the required equation of a straight line. Next one, passing through 2, 2 root 3 and inclined with the x-axis at an angle of 75 degree. So when an inclination is given, we can find the slope of the given line by using m is equal to tan theta. So we have m is equal to tan 75 degree. So the value of tan 75 is 1 plus root 3 divided by 1 minus root 3. So now if we substitute in the slope intercept form, we have y minus y1 is equal to m into x minus x1. So y minus y1 is 2 root 3 is equal to m is 1 plus root 3 divided by 1 minus root 3. X minus x1 is 2. So we will get this as 1 minus root 3 into y minus 2 root 3 into 1 minus root 3 is equal to 1 plus root 3 into x minus 2 into 1 plus root 3. So rearranging this, we will get 1 plus root 3x minus 1 minus root 3y, and taking 2 common here plus 2 as a common factor, we will get this as root 3 into 1 minus root 3 minus 1 plus root 3. So this is equal to 0. So this is the required equation of the line. Next one, 2-point form of a line. So 2-point form of a line means we have already found the slope of a line when 2 points are given. So that is, it is given by y2 minus y1 by x2 minus x1. As in case of slope intercept form, this is the same, but here the slope is calculated using the 2 points. So therefore here point x1, y1 is considered as the point from where the line is passing, and the other point is used to calculate the slope of the line. Thus, y minus y1 is equal to y2 minus y1 by x2 minus x1 into x minus x1 represents the equation of a straight line. The formula can also be written as y minus y1 by x minus x1 is equal to y2 minus y1 divided by x2 minus x1. So this can also be used to find the equation of a line. Write the equation of the line passing through the points 1, minus 1 and 3, 5. So let us consider 1, minus 1 as x1, y1 and 3, 5 as x2, y2. So therefore here this becomes y minus y1, which is plus 1, divided by x minus x1, 1, is equal to y2 minus y1, which becomes 5 plus 1, and x2 minus x1, which becomes 3 minus 1. So we have y plus 1 divided by x minus 1 is equal to, so this is 6 by 2 cancels 3. So y plus 1 is equal to 3x minus 3, or 3x shift here minus y plus 1, when it comes there it becomes minus 3 minus 1 minus 4 is equal to 0. So 3x minus y minus 4 is equal to 0 is the required equation of the line using 2-point form. The next one is slope intercept form. So the equation of a line with slope m and making an intercept on y-axis is y is equal to mx plus c. So here you can observe a straight line which is intersecting the y-axis at certain point, and this point of intersection is written in the form of 0, c. So this C is called as y-intercept because it is intersecting y-axis. That's why it is called as y-intercept. And the slope of the line is calculated using m. So this is the difference of 2 points, y2 minus y1 with respect to x2 minus x1. So whenever the slope and y-intercept are given, so this is the equation we use to find the equation of a straight line. If suppose any line cuts the y-axis at origin, then here the value of C will be equal to 0. So then the required equation will be of the form y is equal to mx. So if any line passing through the origin always have an equation in the form y is equal to mx, where y-intercept is 0. Suppose in case we have a line which cuts only x-axis. So this intersection will be in the form of d comma 0. Let me consider this as point d comma 0. Here d is called as the x-intercept. In such case, the equation of a line is given by y is equal to m into x minus d. So this is the equation of the line when x-intercept is given, and this is the equation of the line when y-intercept is given, or any line which is passing through the origin, any line. But the thing is, it always should pass through the origin. Then the equation of the line is y is equal to m into x. So let's take an example. Write the equation of the lines for which tan theta is equal to 1 by 2, where theta is the inclination of the line and y-intercept is minus 3 by 2, x-intercept is 4. First they have given tan theta is equal to 1 by 2. What do you mean by tan theta? It is the slope of the line or gradient of the line. So that means they have given you the value of m. So therefore m is equal to 1 by 2. In the first case, they have given y-intercept, that is c is equal to minus 3 by 2. So therefore the equation of the line is in the form of y is equal to mx plus c. So y is equal to 1 by 2x minus 3 by 2. Multiply 2 on both sides, we will get 2y is equal to x minus 3, or x minus 2y minus 3 is equal to 0. So this is the required equation of the line. Now in the second case, they have given x-intercept is 4. X-intercept means d. d is equal to 4. So then the equation of the line is y is equal to m into x minus d. So y is equal to 1 by 2 into x minus 4. Multiplying 2 on both sides, we get 2y is equal to x minus 4, or x minus 2y minus 4 is equal to 0. So this is the required equation of the line. So this is a slope intercept form with respect to y-intercept and slope intercept form with x-intercept. Find the equation of the straight line intersecting the y-axis at a distance 2 units above the origin and making an angle of 30 degree with positive direction of x-axis. So we have x and y-axis here. So let this be 1, 2. We have a line which is intersecting y-axis at a distance 2. This is 2 units from the x-axis, and it is making an angle of inclination of 30 degree with the positive direction of x-axis. So by angle we can find the slope, and they have given the intercept. So therefore here C is equal to 2, M is equal to tan 30 degree. Angle of inclination is given and the value of tan 30 is 1 by root 3. So using slope intercept form, we have y is equal to mx plus c, y is equal to 1 by root 3x plus 2. So multiplying this, we will get root 3 y is equal to x plus 2 root 3, or we can write this as x minus root 3y plus 2 root 3 is equal to 0. So any form, reduce it into the linear equation form. Thus x minus root 3y plus 2 root 3 is equal to 0 will be the required equation of a straight line. So thus in this session we have learned the various equation of a line. The first thing is we have learned the equation of horizontal and vertical lines. So the equation of horizontal lines will be of the form y is equal to a or minus a. And similarly, the equation of vertical lines will be of the form x is equal to plus or minus b, depending upon the position. Next, we have the equation of a line in point slope form, which is given by y minus y1 is equal to m into x minus x1. Next, we have the equation of a straight line in 2-point form, which is given by y minus y1 by x minus x1 is equal to y2 minus y1 divided by x2 minus x1. The next one is we have learnt the slope-intercept form. So, slope-intercept form, when y-intercept is given, it is mx plus c. Slope-intercept form, when x-intercept is given, it is m into x minus d. And slope-intercept form, when the intercept is 0, is y is equal to mx. So, this is the only line which passes through the origin, and the rest of the lines will have an intersection with either x-axis or y-axis or both. So, I'll meet you in the next session with the new concept. Until then, keep watching, keep learning and keep exploring. Thank you.